All right, we are up to the final lesson of the Python primer, which will be taught by Eric Sivonxay on building your own Python environments.
Sean, thanks for the introduction. First off, before we get started, I'll show you guys where to navigate to in order to get to the contents for this lesson. So if you just go back to the home, or I guess if you want to go back one page into the primer, you can do that, but we'll just start from the start. So if we go to the home by clicking the home icon on the top bar, we can go into the workshop folder, the primer folder, and then the folder titled O4 underscore Python underscore environments. So if we go ahead and click this, we'll see a couple different IPython notebooks. The ones that we're going to be interested, at least for using within CoCalc, are going to be the exercises dash blank and one pip and Conda. I'm going to go ahead and open exercises blank. So these are the few exercises we'll go over in our lesson, and then I'll go ahead and create a new Python notebook as well, or IPython notebook, so that I can work from scratch. You're welcome to open the other one if you want, but it is all filled in, so you won't be able to type along as easily. Let's see. Uh, so I'll go ahead and create a notebook, a Jupyter notebook. I'll select the default kernel, and we can go from there. So I'll just give everyone a couple minutes to locate what what we need and to create a new notebook if they want to follow along typing. All right, so it's 2:20 on my time, so we'll go ahead and begin. Before we begin, quick introduction for myself. My name is Eric Sivonxay. As Sean mentioned, I am a graduate student in Christine Persons Group, and I use the Materials Project or the Materials Project codes on pretty much a daily basis. Today, we're going to be talking about package managers, Python libraries, and Python environments. Um, so just to give a little bit of background, so one of the reasons that Python has risen to the top amongst the scientific and data science community is that Python is a relatively simple language to learn, which hopefully you guys have seen over the past 3 lessons. It's also platform independent, and most importantly, it has access to a wide range of open source packages and libraries. Um, that aid in science or data analysis. You guys might have seen that you guys have used Python libraries already, in particular in the lessons where you use the import math statement or the import PyMongo statements. So what we're going to do is we're going to look at how we install different Python libraries and how we can take advantage of those in our codes. Uh, so, oh, looks like we have a guest here. Uh, so the to start off, there are a couple of different package managers that you can use in Python. They are pip and conda, which are the two most commonly used ones. Uh, pip is the one that comes pre-installed with Python by default, and it's pretty much the de facto standard. I'll note here that everything that we're about to talk about is usually run in the command line, but for the sake of clarity and for demonstration purposes, we're going to run this in the workshop. And the way we're going to run shell commands is just by using the exclamation point command, and that'll just run things in the shell command line as we type commands afterwards. So let's go ahead and just look at pip for a second. So if we want to use pip, we just type the exclamation point and then type pip. I'm going to actually just type -- version just to see what version we have on our system. So now we can see that we have pip and it's version 21.0.1. The exact version isn't really important right now. It's just important that we have pip. So if we want to look at the functionalities that pip offers us, we can use the help command. The way we do this is we type exclamation point pip -- help. And I believe if you just type exclamation point pip, it should also show the help screen as well. But for clarity, we'll just include all of the -- help. So this will list all the different commands that we can use for this specific package. And I'm going to highlight the ones that we're going to use today, which are going to be install and uninstall, which are fairly obvious in what they do. They will install packages for you or uninstall them. We'll also use freeze, which shows the list of packages that we have installed. And then we'll also use show to query individual packages to see whether or not we have them installed and what versions of them we have. So I'm going to go back to the bottom here, and we're going to go ahead and use the pip freeze command. So exclamation point pip and then freeze. So this will spit out a whole bunch of text, but this will all correspond to all the different packages that we have installed. So right now it's showing all of the things on our default environment, Python environment, which is what what Patrick has set up for this workshop. And for those of you who have looked ahead at tomorrow's lessons or the day afterwards, what you'll see is that you recognize a few of these, especially we recognize PyMatGen. It's here somewhere. PyMatGen right here. And we also have like map miner, fireworks, and all the different materials project codes. And so this is a quick way to check what you have in case you need to install it or uninstall it or etc. So now that we can check what packages we have, how do we actually find packages to install? Python packages can be found on the Python package index, which is also known as PyPy for short. Um, it's an online repository of third-party packages, and we can visit the link right now. So I'll just create a new tab and then go to pypi dot, or I think it's .org. Yes, it's .org, and we will come to this website. Here we can search for packages, and so in the case in which I know exactly which package I want to use, I would just type it into the search and find it. Alternatively, packages can also be found on GitHub, especially if they're highly developmental codes. Or if you need, you can also Google things, and this is Google is always your biggest friend in terms of finding codes, especially if you don't know exactly what you need. So for demonstration purposes, I'm going to look for a specific package that I know of that is fairly useful within material science, and that's MD analysis. So I'm going to type MD analysis into the search bar and hit enter. So we get a whole bunch of different results, but I'm just going to click on the first one. It's MD analysis 1.1.1. So when we click on it, we get to a landing page, and this landing page contains a lot of information about uh, what the package is for, its documentation, its installation, instructions, how you contribute to it, or how you might even cite it if you use it in your paper. And additionally, we can look at the release history, which shows all the different versions of this code that have been released. You can see they go all the way back to 2011 when the code probably first came out. Additionally, you'll see that there are versions that are tagged as, I guess, this version or released versions. And there's also things that are in pre-release state, which is like a beta code. Um, these might offer more functionality or improved performance, but usually they can be less stable. So typically by default, when you install programs, they usually default to one of these released versions. So I'm just going to keep in mind the different versions here. I'm going to keep in mind that there's a beta and we'll want to try to install this later. So I'll keep in mind that it's 2.0.0 B0. So I'll go back into CoCalc. And before I install it, I'm just going to check to make sure it's not installed, or else there's no reason in demoing how to install it, right? So we'll type exclamation point pip show, and then we'll type MD analysis, shift enter. Okay, so we see that the package is not found, meaning that it's not installed on our system. So we can go ahead with our installation. So to install MD analysis, we just need to use the install command as we saw in the pip help. We'll type exclamation point pip install MD analysis. Shift enter, and it'll start to go through the installation. So first what it's going to do is it's going to look for all the other modules that are required by MD analysis. So you might need the math libraries, you need the scientific libraries, and all these within this package. And so it'll make sure those are installed before installing MD analysis. Okay. So now if we go back and use our pip show command again, pip show MD analysis, shift enter, we can see now we actually find something. And this gives us more information on MD analysis. So we can see it's an object-oriented toolkit used to analyze molecular dynamics trajectories generated from multiple different molecular dynamics codes. All right, so now if we want to use this code in our environment, so let's say if we wanted to do something with it, we need to import it. Before we do that, we have to restart our kernel. So basically we need to reload our environment to say, so that it will look for all the new codes and all the updates we've done. And to do that, what we can do is either click this refresh button next to tab in this, what is this? This is like the fourth bar down. Or we can click kernel and then just restart kernel. And we'll verify, yes, we want to restart the kernel. So it'll give us a little message saying that it killed the kernel, sorry. And then when that goes away, we're welcome to use our terminal again. our IPython notebook again. So now we can just simply import MD analysis. And then if we run that line, we see it successfully passed, no errors. And then we can do whatever we want with this package. So in this case, we'll just check the version of it. Uh, now, analysis dot underscore underscore version underscore underscore. And now we can see that within Python, we can actually access the code within MD analysis and we can check its version. All right, so now let's say that we looked at version 1.0.0 and it kind of does what we want, but we want to go on to the latest beta version. We want access to all the latest and greatest code that they might have there. How do we actually do that? So what we'll want to do is we'll want to pip install again, but this time we're going to add the -- upgrade flag. And we're going to specify that we want MD analysis version 2.0.0 B0. Okay, so if we run this code, we're going to get a whole bunch of things. So it's going to do the same thing as before. It's going to try to install the dependencies before uninstalling the previous version of MD analysis that we installed 1.0.0 and then installing the newest version. So now if we go !pip show MD analysis, we'll see that now pip tells us we have version 2.0.0 B0 installed. And likewise, if we refresh our kernel once again, so restart kernel, restart kernel, and then restart. If we do the same thing where we import MD analysis and then type MD analysis dot underscore underscore version underscore underscore, we can see that now it tells us we're in the 2.0.0 beta. All right, so that's how you install packages. And you can imagine doing this for any number of packages or any number of libraries for any purpose that you want, whether it's to do some sort of matrix operation or to do some sort of analysis or machine learning. So next, let's talk about installing packages that may not be on PyPy, things that are on open source repositories such as GitHub or Bitbucket or GitLab, etc. So I'm going to demonstrate with a code called mpmorph. So if I open a new tab, and I'm just gonna search mpmorph into Google. Oops, sorry, mpmorph. I'm just gonna go to the materials project / mpmorph GitHub repository. So this is a specific code. In this case, it's a code that runs and analyzes ab initio molecular dynamics calculations using VASP. But one thing, if you'll notice, if you want to check, it's not on PyPy. So how do we install this? Well, the first thing that we're going to want to do is we're going to want to grab the download link for this code. In order to do that, we'll click on this little green button here in the middle that says code with the little download arrow. Click on that. Make sure we're under HTTPS, and then we're going to copy this link just by clicking here, or we could just highlight the link itself and copy it. Now we'll go back into our materials project workshop on CoCalc, and then we can start to manipulate this. So I'm gonna create, oh, sorry. I am going to type git clone and then this link right here. So basically what this is going to do is it's going to use git to download this repository. So now it's finished downloading, and if you go back into your files, you'll actually see now that there's a folder called mpmorph. But we're going to install this code directly from that folder. The way we do that is by typing !pip install mpmorph, and then we'll say it's a folder with the slash. And then now we type shift enter. And then now it's going to install it. So now it says it's successfully installed. And if we again go type pip show mpmorph, we see that mpmorph is now installed. All right. So now that we've installed a package, now you can think about, oh, what if I need to remove a package if I've installed something incorrectly, or if I no longer need a code that I previously needed? Very simple. We just need the uninstall command. So we type pip uninstall, uh, and then we're going to type -y to give confirmation. So one thing with the uninstall is that it will, before it actually uninstalls anything, it'll ask us, do you really want to uninstall this? The issue with doing this in the IPython notebook is that we can actually tell the command line yes. And so it'll just hang there and sit there until we have to cancel the operation. But what we can do is we can give it the -y flag to tell it, yeah, we give confirmation ahead of time. So I'm going to go ahead and do that analysis and then shift enter. So it found it and it uninstalled it. Now if we, again, use our pip show command and the analysis, we can see that the package is again not found. And we can do the same for mpmorph as well, even though it's installed out of a folder. We type pip uninstall -y mpmorph. All right, and so after executing that, now we no longer have mpmorph either on our environment. All right, so at this point in time, we can go to our exercises -blank notebook. And I have two very quick, very short exercises for you to work on. So we'll give we'll give 3 to 4 minutes on this, and then we'll come back and I will show you the solution real quick, and then we'll get back into the next section. All right. Sorry, just to butt in for a little bit. You only need to work on the first two exercises right now, the ones under pip. We'll get to the Conda exercise after our Conda section, which is coming up next. All right. We can start up again. Hopefully, you guys were able to figure out just so that we can go through it and make sure everyone's on the same page. Let's go through this exercise. So the first exercise is to downgrade NumPy to version 1.19.5. And the easy way to do this is just to specify the version that you're installing. Downgrading is the equivalent of just installing the lower version number. So we can type !pip install numpy and then just type equals 1.19.5 and then type shift enter. So now it uninstalled version 1.21.1 and installed the downgraded version. Now the next exercise was to upgrade NumPy back to the latest version. Two ways you could have done this. You could have recognized that the old version was 1.21.1 and then just specified that as we did here. Or the other way to do it is to type !pip install --upgrade and then type numpy. So what this will do is it'll basically tell pip to just upgrade numpy, and then numpy will or pip will by default look for the latest version of the code it's trying to install. And so now we have numpy 1.21.1. All right. So now let's go back into our other notebook, and then I will create a big breaker section. And so this is Conda now. Oh, and I'm going to go ahead and create a lot of empty cells beneath my current cell, just so that I can type not at the bottom of the screen. I know that it might have impeded you guys looking at what I was doing. Okay, so let's talk a little bit about Conda. So I mentioned Conda was a package manager that we could use to manage packages in Python. But I also told you that pip did the same thing. So you might be wondering, why do I need to learn Conda? Why do I need to use both? Well, the difference is that pip is exclusively meant to manage Python packages, whereas Conda is a general purpose package manager, and it enables the installation or the management of packages that might be written in other languages or other pieces of software. Additionally, Conda installs pre-built binaries rather than building from packages. Of course, it is possible to tell Conda to build from source, but usually it will install from a binary. Also, Conda allows you to create virtual environments. And virtual environments are very powerful tools that we have at our disposal to create sandboxes where we can install local collections of packages or play around with uh, what codes we're using and what we're doing in that specific environment or sandbox without impacting what the rest of our system is doing, such that if we find that we've messed up a sandbox in terms of installing conflicting packages or things that don't work well together, we can just delete that sandbox, create a new one, and we have not impacted our ability to run code. Additionally, within these virtual environments or sandboxes, we can use different versions of Python. So whereas pip is constrained to the Python that we have installed because it comes with Python, Conda, we can have multiple different versions. So I can have one environment that runs in Python version 2, and then another one that runs in Python version 3. So that's very useful for us, especially when we're trying to use codes that may be legacy codes that were written 10 years ago that don't play nice with the other ones. All right. So before I get into talking about Conda specifically, I would like to mention a package or a program called Mamba. Mamba and Conda are in pretty much every case functionally identical, except the difference is that Mamba is written in C, and basically just runs a lot faster due to faster code, and it allows for parallel downloading of files. The reason I mention this is because Mamba is something that's new and upcoming, and it's something that we're going to use now so that we don't have to sit through and wait for Conda to download a lot of things, because we want to take advantage of the speed. But everything that I'm going to be doing in this lesson, wherever you see me use Mamba, you can directly replace that with Conda. So, and for more on that, you can check the pre-filled notebook as well. So I'm gonna go ahead and look at what Mamba has to offer us. So exclamation point Mamba dash dash help. This, like pip, will just give me a list of the different commands that I can use, and we can see a lot of these do revolve around using packages, whether it be install or uninstall or search. So another thing that I want to show off real quick is the exclamation point Mamba env dash dash help command. So there's the environments, I guess, module within Mamba, which allows you to manage environments. So this may be creating an environment from a preset template file, listing the environments that you have, removing environments, or configuring them. So let's go ahead and use the list command just to see what we have on our system. So we type exclamation point Mamba env list. And we see that on our system, we have our base environment, which I believe everyone has. And I don't believe everyone has this, but there is a environment called Patrick on my system, or on my instance of the workshop. So if we look at this, we can see that there's a star or an asterisk next to the base. That means that is our currently active environment and the one that we're going to be installing code to if we just directly use a conda install. It's also worth mentioning, and I believe someone asked this in the workshop 2021, um, you can also use pip in conjunction with conda. So if you're using conda or mamba to manage environments, you can also pip install codes, and it will play nice with conda, um, especially for those Python packages. Okay, so now that we see which environments are here, let's go ahead and create one. This is what we're going to try to do. So to create one, we just use the mamba create command. We'll add the -y to tell it yes in advance, much like pip. We want to give it permission ahead of time to do this so it doesn't ask us for confirmation, and then we'll give it a name, and we'll just name this temp and temp environment. And then additionally, we can specify that we want a specific Python. So I'm just going to say Python 3.9. What happened here? Let's see. Do I need to do double equals? No. Okay, let's see. Dash, dash. Okay, let's just get rid of the Python for now. Not sure why it's causing issues. All right, so now that we've done that, Mamba has created our environment. So now what we can do is it tells us in order to use this environment or to interact with this sandbox, we need to use the conda activate temp-env command. Before we use that, let's go ahead and look back at our lists of environments. So type mamba env list again. And we can see now on top of our previous two, the base environment and the Patrick environment, we can see now we have a temporary environment as well. We notice that the asterisk is still on the base environment because of course we have done nothing and done nothing to activate our environment right here. So in order to use our environment, we need to make sure we activate it. So in order to do that, we need to learn another command. So previously we used the exclamation point to run command lines. but the exclamation point only allows you to run one line in the command line. In order to run multiple, we need to use the %bash magic command. So this tells IPython or Jupyter that this whole entire cell should be executed as a command line, a series of command line inputs. So what we're gonna do is we're gonna type conda activate temp env, and then type mamba and list. Now we don't need the exclamation point anymore, but if we hit shift enter, oh, okay. So actually, the conda shell was not initialized. So I'm gonna change from conda to source. Um, if you're doing this on a command line input, what you would do is you would just follow its instructions and type commanda init bash, and then you can run the code. But since we're in a separate environment, I'm just going to change to source. So now we can see that this asterisk is in front of or next to the temp env environment, which means that within our specific cell, we are now in the temporary environment. Now, just to show that it is not the default activate environment still, if we type exclamation point mamba and list, we can see that by default, it's still going to go back to the base environment. So whenever we want to interact with our environment that we've just created, we need to use these lines of code, the %bash, source activate, temporary environment. So I'm going to go ahead and copy this. I'm going to go right click and copy so that whenever I need it, I can just paste it. Okay, so now what I'm going to do is look at the packages that we have installed. So I'm going to paste those two lines of code to activate our environment, and then type mamba list. Shift enter, and now we can see the output from Mamba, and under name version build channel, we see no packages, meaning that we have nothing installed on our environment, and it's clean, and we can install whatever we want on it. Okay, so now let's talk about installing packages to this. So we want to install things using Conda rather than pip. So how do we do this? Well, again, we're going to need to start with our lines of code. And then before we get into the installation, I'm going to show you a little bit on how to find things. So with Mamba, we type Mamba repo query search numpy. So this is the same thing that what's going on? Query numpy. This is not working. Why is this not working? Okay. Let's see. Does it want me to just type this? No. Okay, I can just try search numpy. Okay, so I'm going to use search instead of repo query. It's going to take a little bit longer because it is not going to do this in a parallel fashion, but it should be able to find the different numpy packages I have. Right. Okay. So now Mamba will give me a list of the different NumPy packages we have access to within Conda. So we can see, of course, all of these have the name NumPy, and there's different versions to these. And then I'm going to scroll all the way to the bottom. What we can see is that on the right-hand side, the far right column is going to correspond to channels. We see that there's packages/main and there's Conda Forge. So the way that I want to explain this is that Conda Forge is very similar to PyPy, where it's a community host, or it's a hosting of community third-party packages. So things that aren't officially hosted by Anaconda. Whereas there is another set of packages in a channel called packages/main. This is one of the default repositories, which are the officially hosted um, packages by Anaconda. Uh, with this, though, I'll point in mind that Conda Forge, as it's managed as a third-party community-driven repository, it has a lot more of the more recent versions of the code, so it's more up to date. So usually when we're installing code, we usually use the Conda Forge channel. And so when we install NumPy, what we're going to want to do is we're going to want to specify that we want to use the Conda Forge channel. So let's do that. So I'm going to, again, paste in the code to activate our environment. And then we're going to type Mamba install. We're going to, again, put -y NumPy. So we're going to install NumPy, and then we're going to specify -c, which tells Mamba use the channel Conda Forge. Hit Shift Enter. Okay, now this doesn't like it too. What is going on? This was working yesterday. What's going on? I have not a clue. Sham, do you have any ideas what's going on? No, maybe not. Okay. Let me try just using Conda. Maybe Mamba is giving us issues. Maybe the install of Mamba is having issues today, or it was incorrectly configured or something. So we're gonna directly change the Mamba command to Conda. This might take a little bit longer because now as we're installing this, it's going to want to install or download things in a more sequential manner. But now we can see, okay, it's downloaded all of these packages, and then it is installed what we wanted. So it's executed the transaction, it's done. So now what we can do is, again, we'll just check what we have installed. So second, we will paste that line of code again to activate our environment, and then we'll type Mamba list. And then Mamba will now list the packages that we have, and now we can see we have NumPy version 1.21.1 installed from the Conda Forge channel. Okay, and we can install any number of packages from the Conda Forge channel, and if you want to look up packages that you might want to install, you can Google them, or you can search what is it? The Conda Forge repository. And again, if you Google Conda Forge, it'll pop up with the repository. All right. So next, now that we have installed different codes, how would we use it with a Jupyter notebook or a IPython kernel? For demonstration purposes, we're going to do it within CoCalc. And the way that we're going to want to do this is we're going to need to create a new kernel. So if I look at the kernel, so I select kernel on this drop-down menu, we can see that there's only one kernel available to us. Under change kernel, it says we can only change to the Python 3 IPy kernel, which is our default one. What if we wanted to use our own environment as a kernel? Well, we'll have to create one. So I'll show you how to do that. So the way we do that is within our environment, we're going to want to execute a few commands. To do this, I'll just, again, activate this. And then I want to install the IPyKernel package. So Mamba install IPyKernel. Oh, let me put the -y here. Shift Enter. Is this going to work? Nope. So, all right, I'm going to switch back to using Conda now. All right. So Conda install ipykernel. It will start to gather what it needs to, and then it will download and install everything. Great. Oh, so now it's installed. So now what we need to do is we need to look at the Jupyter kernel specs and see whether or not we can create one. So I'm going to type !Jupyter and then type kernel spec list. Hit Shift Enter, and it tells me the available kernels are Python 3, which is the default one. And that's again what we saw in the menu. So let's create one, a new one that corresponds to our environment. So we type !, and then now here's the hard part, or it's a little bit more difficult. So I need to know where this environment is. So I need to actually Mamba and list so that I can get the path to my Conda environment. So now I can execute this. What I want to do is execute the Python within the temporary environment to create an ipykernel. So I'm going to type !, /home/user/.conda/env/temp, and that's just the location of this package right here. And then I'm going to want to go into the bin folder and then go into Python. So I will use the Python within my temporary environment. I will type -m to run it as a module. I'll run ipykernel install. I'll want to install this to my specific user and not for everyone else. And then I'll type --name and I'll just give it a name, temp and kernel. And then if I hit Shift Enter, it should tell us we've installed the kernel spec. So now if we again look at the list of kernels that we have installed, !Jupyter kernel spec list, what we see is that now our temporary environment kernel has now been added. So now we can use this. Let's go to kernel. We see it's not on this list, but if we hit refresh kernel list and then go back into it, now we can see we have a new kernel. So this corresponds to our new environment. If we click on it, it'll reset our environment, and now we can use it as is. So we could say import numpy and hit Shift Enter, and now we can use numpy. All right, so now we've talked about installing codes as well as how we set it up so that we can use it within our Jupyter environment or our CoCalc environment. Now let's talk about how you remove programs. So this is going to be very similar to pip. It's a very simple command, but let's just type !Conda and then remove. We'll type -y. Oh, sorry, my bad. I am now going to remove the environment. So let's say we have an issue with our environment or we no longer need our environment. How do we do that? So it's not similar to pip, my bad. So we're going to do conda remove -y, and then we're going to type --name temp env. So we're specifying we're going to remove temp env, and we're going to type --all. So this is going to remove everything that is involved with our temporary environment. All right, so now it's executed the transaction and it's done. And now if we do conda env list again, we see that the temporary environment is no longer in our list of environments. So we've successfully removed it. Finally, for completeness, I'm going to remove that kernel spec, the temporary env kernel, so that we're not pointing to nothing. I'll type !Jupyter kernel spec remove, and then we're going to type -f temp env kernel, Shift Enter. And now we've removed this kernel. So again, if we type Jupyter kernel spec list, we can see that it is no longer here, and we're back to where we started, where we only have the Python 3 kernel available. All right, with that, thanks for bearing with me on this specific section. We ran into a few issues, but I feel like we've demonstrated very well how Conda and Mamba are interchangeable. But Mamba is, of course, the new upcomer that should be faster, but it's a little bit less stable. And of course, we had issues. But let's just go into our exercises, and let's try to do our Conda exercise. So what we're gonna try to do is we're gonna try to create a Conda environment. Of course, the name, you can name it whatever you want. And we're gonna install enumlib, specifically version 1.0.4 from the MatSci channel. And enumlib is a code that you can use to enumerate lattices if you were to look for, I guess, alloys or other materials of interest. So I'm gonna give 4 minutes again for this, and then we'll come back, talk about it, and then move on to the next section. All right. All right, let's go ahead and resume. Hopefully you were able to work on these exercises and hopefully figure them out, or the exercise and hopefully figure it out. If not, we'll go over it now. So the first thing I want to do is I actually want to search for enumlib so that we can see what different versions exist. So I'm going to type exclamation point conda search uh, enumlib -c MatSci. So we're specifying the channel and we want to use MatSci instead of Conda Forge. Okay, so now it's going to load the specific channel and it's going to do the search. Okay, so now what we can see is we actually have enumlib version 1.04 in MatSci, and we also have enumlib, actually a later version in CondaForge. I would probably recommend if you were to use this, to use the CondaForge install, but for demonstration purposes, I just wanted you to interact with the MatSci channel. All right, so let's go ahead and work through this exercise. So the first thing we want to do is create a Conda environment. So like before, we just type !Mamba, or let's do Conda create -y --name, and then we're just going to say enum lib and run that code. It will work through the install or the creation of the environment, and now it's created. And then as before, we're going to need to activate the environment, %bash, source activate enum lib, and then from here we can install enum lib. So conda install -y enum lib equals 1.0.4 -c matsci. Shift enter. Oops, sorry. And we can see now enumlib was installed. Okay, great. That concludes the lessons with pip and conda, and now I'm going to migrate off of CoCalc for the last section of our lesson. So what I'm going to do is I'm going to create a new tab, and we're going to go into Google Colab, also Google Collaboratory. So it's colab.research.google.com is the link that we're going to go to, or you can search Google Colab and just click on the first link. So I'm just going to hit cancel here. Hopefully you're able to find it. So I'm also going to check to make sure it's the first search result on Google. Okay, it is. So you can do either way. Type colab.research.google.com or just search it. So a very brief introduction to Google Colab. Google Colab is basically like IPython notebook or Jupyter or CoCalc. It's a hosted Python notebook service that's based on Jupyter, and it provides people with free access to computing resources. Colab allows, much like the rest of the Google Suite, for quick and easy sharing of files, especially these Jupyter notebooks, without requiring people to download anything or set up any Python environment. So this might be good for interacting with your collaborator who does experimental work, who might not know how to set up an environment and you don't want to teach them, right? Also, Google Colab allows you to use computing resources such as GPUs and TPUs, although I will point out that it's no substitute for a supercomputing center where you can get a lot of calculations done. Google Colab does not let you run quite that many calculations, and they also will cut you off if you are using their service too heavily. So by default, we get access to CPUs, and then we can add GPUs onto our service. So what I'm going to do is I'm going to open one of the notebooks that we have prepared within the Materials Project Workshop GitHub repo. So the way that I'm going to do this is click on File, and then Open Notebook. This will come up with this pop-up, and then at the top, I'm going to hit GitHub. So it's going to ask me to enter a GitHub URL or organization, and we're just going to type materials project, all lowercase, no spaces, materials project, and then hit enter. So hopefully it comes up with some sort of repository telling you that you've typed the right thing in. And then we'll click the drop-down menu and click on workshop. From here, if we scroll down, we can find at the very bottom, probably, the workshop primer, 04 Python environments, Google Colab blank notebook. So it's this one right here. So I'm gonna wait a little bit, so hopefully everyone is able to search for this, and then I'll open it. So again, to reiterate, we're going to go under GitHub on this menu. Then we're going to type in materials project, all one word, no spaces. And then we're going to go into the workshop repository. All right, so I'm gonna click on this now. So to Google Colab, blank. All right, so as I mentioned before, this Google Colab is just like any other IPython notebook. We can run any code we want. Say we want to do like 10 plus, or sorry, 10 plus 2, shift enter. Google's going to give you a warning saying that this notebook was not created by Google and it is being shared with you. Please make sure that you understand this before doing so, because it could ask to read credentials or some other things from your Google account. So I'm gonna just hit run anyways, because um, this notebook is safe and I authored this myself, right? So we're able to run anything that we would in Python in this notebook as well. So Google Colab specifically is used very dominantly within machine learning, but we can actually use it for our scientific packages. But if we look at the pip freeze command, as we did before, we'll notice looking through all the different codes that are installed, there's a lot of stuff that's installed for for machine learning, such as TensorFlow, PyTorch, and other different packages. But I'm going to show you later on how to install our material science codes onto this. Additionally, within Colab, we can use what are called code snippets. So these are, sorry, let me make this bigger so you can see. So you can use code snippets. So these are preset codes that help you do things like plotting, interactive plots. And all you do is you add the code snippet and then you change it to include your data. So let's, as an example, we want to insert a code snippet. So we click on insert in the top bar and then we click on snippets. So it'll pop up on this left hand specific bar that lets us do anything we are, look at the different code snippets that are installed or by default provided to us. So I'm just going to click on one just by random. So we can say visualize the scatter plot. Let's hit the arrow. It'll add the code in. We'll type shift enter. And now there's some sort of plot that we can interact with and do whatever we want. We can go into this cell and then edit the data to just point to our specific data, and then we can just plot it easily for very quick plots if you want. So the other thing Google Colab has that I mentioned is access to different resources. So before I tell you how to access GPUs and TPUs, I want to talk about runtimes in Google Colab. So Google Colab has what's called a runtimes, which is the equivalent of on Colab or CoCalc, the kernels that we have. The difference is that each of these runtimes that Google Colab has runs on a virtual machine somewhere in Google's server farms. But we can actually view our active sessions by clicking on runtime, manage sessions. And we see that we only have one session and we can terminate it if we want. But if we want to change our runtime from a standard runtime to one with GPUs, what we can do is click on runtime and then click change runtime type. So from here, we can add a hardware accelerator, such as a GPU or TPU. So I'm going to pick GPU and then we can hit save. So it's going to reset our environment. As you can see in the top right-hand corner, it basically started initializing and then connecting as well. And then if we go to the same thing, change runtime type, we can see that we are now in a GPU runtime. So another thing I didn't mention before is that Google Colab is not like CoCalc, where we can't actually go in and interact with your notebooks directly. So if you have any questions or if you're having trouble running anything, please just post in the Workshop 2021 Slack channel and someone will hopefully be able to help you there. So back to our runtimes. Now that we have a GPU runtime, we can say test out this example code that Google has provided. This basically is a code, and I'm going to run it now. It's a code that basically runs some sort of convolutional filter over a set of 100 random images. And it does this on both the CPU and the GPU. And then it compares the speed or the time it takes to run on both the CPU as well as the GPU. And this code may take a little bit to run. I think it takes like 40 seconds to run. But what it'll show is that the GPU for this specific instance runs 80 times faster, or about 80 times faster than the CPU. So now we can see that, right? The GPU speed up is 80 times. Okay, so talking about what we want to, which is installing our material science code on Google Colab, we want to use Conda, but by default, Conda does not come pre-installed on Google Colab. So what we need to do is we actually need to install it. So if I type which Conda, we can see there's nothing installed. So we actually do need to install it. So in order to do this, you can install it through the traditional method of downloading the Conda executable or binary and then installing it onto the system. Or we can take a simplified approach and just use the package that has been created called Conda Colab and just type pip install Conda Colab. If we run this, it will install Conda Colab for us. And then from here, we can simply type import Conda Colab, and then type conda colab.install. So what this is going to do is it's going to download the latest release of Mamba Forge and install both Conda and Mamba onto our system. Like before, as I stated, Mamba is supposedly or is actually faster than Conda in most operations, and we'll use it in this lesson a little bit. All right, so now what it's going to do is it's going to restart our kernel, which is our runtime, and then what we can do is now we can check which Conda. And we'll see now that we have our installation of Conda now, whereas we didn't have it before. So now if we want to install any sort of software, it's pretty much the same as before. We're going to do Conda install and then something, right? But there is a small caveat here, which is that Google Colab, because we have to work within the environment that Google provides, we actually need to maintain some of the versions of code that Google Colab has. Specifically, NumPy, we need to keep it the same version, or else we're going to have conflicts with PyMatGen. So let's say if I import NumPy, and then I print numpy __version, we can see that the version is 1.19.5, and this is the version that we'll want to keep installed on the system. In order to do that, what we do is, as before, just do conda install -q for quiet. So I'm basically just muting conda and telling it not to go through, print out all of the information that it wants to, or all the warnings and everything. And then I'm going to type -c conda forge. I'm going to install PyMatGen, and I'm going to install NumPy, but I'm going to install NumPy version 1.19.5, and then again, we'll want to do -y. Again, I can also use Mamba in this instance, and then I could just run it. Because we're kind of behind on time, I'm actually not going to run this because it'll take, I think, somewhere around 2 minutes to run. But you can, in your own time, run this code to install PyMatGen. So if you wanted to install all these specific codes that the materials project uses, you'd have to go through this call of Mamba install with all the different codes like fireworks, custodian, map miner, etc. But every time you did that, it would start installing the latest versions of whatever packages it could find, right? So it might find SciPy, the latest version might change. But the issue with that is now we don't have a consistent environment to use, meaning that maybe 5 months down the line, if we open up our notebook again, we might run into issues where latest version of SciPy doesn't work with whatever code that we've got. So what we're going to want to do is we're going to want to create Conda constructors. I'm not going to talk specifically about creating Conda constructors, but there is a section about how to create your own down below this one. But I'm just going to show you how to install from a Conda constructor that we've created for the workshop as a proof of concept that we can install all the materials projects codes very quickly using this Conda constructor. So what we're going to want to do is I'm going to reset the environment back to its factory settings. So if I go to runtime, factory reset runtime, I can just hit yes. Basically, this says I'm going to reset everything. I don't want any of the codes that I've installed or any of the files I've made. Just take me back to what Google has as the defaults. That way that I don't interfere with this specific installation right here. So first thing I'm going to want to do is I am going to want to install Conda Colab again. So pip install -q conda Colab, shift enter. And as before, it's going to install Conda Colab. And then what we can do is we can import Conda Colab. And then we're going to want to type conda colab install from URL. And then we need to give it a URL. So the constructor that we've built for our workshop is right here. It's this GitHub link. So if you click on this release, you can see the file that we've uploaded here. And then we'll just copy this link address. It's also right here for you. And then in single quotes, we're just going to paste it into that function. So if we run this, it's going to download that specific file that we have, or a template for creating this Colab environment or Conda environment. And then it's going to install it. So this might actually take a little bit of time. I believe it'll take probably 2 minutes or somewhere around there. But at the end of it, you're going to get an environment that's set up with PyMatGen, Fireworks, Custodian, Animate, and Map Miner, which are all codes that you'll use in later lessons on tomorrow or on Thursday. And with that, that concludes our section or our lesson on Python environments. So thank you. And thanks for bearing with me through the small hiccups that we've had. And hopefully you've learned something. If you have any questions, feel free to post them in the workshop channel. Thank you.